All right, we're going to look at lesson 4, our last lesson in set theories, and we're going to talk about Venn diagrams with 3 sets, which adds a whole layer of complexity. So, I can have multiple sets, right? I can have several sets, and they can all intersect in different ways. So, let's look at a few Venn diagrams and talk about where these might be intersecting. All right, so let's look at this first one. Set A intersect B. So I have set A, right, with that circle at the top. I have set B. I want to find where they intersect. Oh, it's this whole region. Notice that we now have a new little section down here at the bottom where this is also intersecting with set C. However, I'm not at the most specific scenario yet, right? I'm just asking where does A overlap with B, and it's this whole section here. So this would be A intersect B. If I'm to talk about A union B, on the other hand, right, that is all of A. Okay, including all of A. And it includes the intersection. And it includes all of B. All right, so even though there's some interlap with C, and I'm not talking about C at this point, this is still every part of A or every part of B or every part that they share, right? It doesn't say, because with an or, right, I can or cannot have other sets involved here. So everything except for really that little explicitly C set in the bottom there. A intersect C prime. So this is where A intersects with everything that isn't C. And so what that's going to look like is it's all of set A minus not including anything that might overlap with C. Another way to think of it is to think about sketching or shading in all of A to start, right? But then erasing that segment that shares anything with C. So A and not C is everything here. Yes, it has overlap with B, but again, I wasn't asking anything about B. I wasn't saying I can or cannot have parts of B. I'm more worried about making sure I've covered up A. And I haven't included anything here that technically is still part of A, but is part of not C. And the last one. So, right, we can have multiple sets interacting with multiple sets, as we can see in the diagram. And we're going to follow BEDMAS, right? We're going to deal with the brackets first. So let's first identify what A union B is. Well, we already did that up above, right? It's everything that's A and everything that's B, right? It was all of this region. I'm then asking, where does this intersect not C? So I need to be then careful about, okay, well, I actually had this section that was part of A and C, and I had this section that was part of B and C that I can no longer include. So I'm going to erase those. What I'm going to do, I'm going to go in, try my best to erase that nicely. And this is what I'm left with, right? So if you need to start with an area, right, start with a piece and then take away once you realize that you no longer have parts that are allowed to be part of your set, you can definitely do that, right? But this is A or B, but not, right? Remember that intersection kind of becomes a but when we start to talk about not including things. It doesn't include those parts that, notice we previously had up here, right, that overlapped. I can no longer include those because I cannot have anything that is part of set C, right? Everything has to be part of the complement of C only. So, right, notice there's a few intricacies, right? A few new areas we need to worry about, a few ways that things can overlap, but also we don't need to stress it too much, right? If I'm talking about some interaction between set A and the complement of C, it doesn't tell me anything about B, so I don't need to stress too much about if things do or do not overlap with B. So let's look at an example of this. The following Venn diagram displays the results of a survey of 100 students regarding which social media app they used in one day. I represents Instagram, F represents Facebook, and S represents Snapchat. How many students used only Instagram? So that's telling me no overlap, right? No Facebook, no Snapchat. So if I'm looking at my Instagram circle over here, right, this whole set, these are everyone who used Instagram. If I want only Instagram, I can't think about the shared Facebook. I can't think about the people who use all three apps, and I can't think about the shared Snapchat. So I'm just worried about this 48 out here on the side. So this would be the number of students who used only Instagram. And it looks like we had 48 students. How many students used Facebook and Snapchat? So I'm looking for the intersect. F intersect S. I look at my graph or my diagram. That's this whole section here, right? Including the people who also use Instagram, because it didn't tell us anything specific about using or not using Instagram. It was just Facebook and Snapchat. So this is F intersect S, which has a total of 7. Right? 6 plus 1. So 7 students in the set F intersect S, right? 6 plus 1. How many students used Instagram or Snapchat? So I'm looking at I union S. So that would be everything in Instagram and everything in Snapchat and everything they share, right? Just everything except for people who used exclusively Facebook and neither Instagram or Snapchat, right? That would be the opposite, the complement. So I have 48 plus 9 plus 6 plus 10 plus 1 plus 21. And if I add all of that together, that gives me 95. So there's 95 students in set I union S. Right, so 95 kids used either Instagram or Snapchat or both and Facebook. How many students used all 3 apps? So this would be, I wanted to give this a name, all 3 apps. Let me get a different color here. This is going to be I intersect F intersect S. And this is that very middle section. This is where all 3 intersect, right? I intersect F intersect S. And it looks like 6 students are in the overlap of all 3. 6 students in set I intersect in set. There we go. I intersect F intersect S. And lastly, what does the number 2 outside the 3 sets represent? Notice I have off in the corner here 2 students that are not, right? If it's not in set I, they don't use Instagram. If it's not in set F, they don't use Facebook. If it's not in set S, they don't use Snapchat. And then therefore it can't be in any of the intersections. So if they don't use any of those 3 apps, this is where they end up. So 2 students use none of these apps, right? Or these social media platforms. So they use none of them. Maybe they use Twitter. Maybe they don't have a phone. Maybe they go outside every once in a while and don't scroll through their phones. All right, thinking about how things interact, thinking about how we could describe those sets. All right, let's talk about soda, a personal favorite of Miss LaRoche. A group of 185 students were asked about what soft drinks they like. All right, so 115 kids like Coca-Cola, 92 like root beer, 100 like Sprite. Right, and that is the general set. So that means the number of students in Coca-Cola, right, or Coke, is 115. That's including any overlap, right? That's not exclusive. The number of students who like root beer is a total of 92. Whoops. And the number of students who like Sprite is a total of 100. 52 like Coca-Cola and root beer. 43 like Coca-Cola and Sprite. 57 like root beer and Sprite. So, again, with these Venn diagrams, start with the most specific you can, that it is the most inclusive, or exclusive, really, and work your way out. So this 25 like all three, right? 25 students are in the set Coca-Cola, Intersect, root beer, Intersect, Sprite, and that's the middle of my Venn diagram here. I have 25 in the middle here. Because as I work my way out, and let's just work our way up backwards, 57 like root beer and Sprite, right? Root beer and Sprite is this whole section here. I know that this has to total to 57. I already have 25 accounted for in the people who like all three. If you like root beer and Sprite and you like all three, I don't want to include you in two separate places. Because if you like all three, you are one of those people who likes root beer and Sprite. Not mixed together, obviously, that's gross. So this total has to sum to 57. So if I subtract the 25 I've already counted for, I'm left with 32 that are strictly just root beer and Sprite, but do not like Coca-Cola. All right, so keeping that in mind, oops, let's move on to the next one. 43 like Coca-Cola and Sprite. So that would be here, Coke and Sprite. I know it has to total to 43, but I've already counted 25 of those. So there's 18 students who just like Coke and Sprite but aren't big root beer fans. They need that caffeine. 52 like Coke and root beer. So again, that would be over here. 52, but subtract the 25 I've already included. 27 like just Coke and root beer. Dark sodas, none of those lemon lime cans of trash. All right, then we can work our way out even further, right? Even more general, right? From really, really specific to very general, we can go in that order. 100 like Sprite, right? So now I'm looking here. 100 minus 25 minus 18 minus 32. Because I know this whole circle needs to total to 100. Right? Because if you like Sprite and you like Sprite and Coke, right? I already know you like Sprite. I don't want to count you twice. So we end up with 25, right? When I do 100 minus 25 minus 18 minus 32. Or 92 liking root beer, that's going to be 92 minus 27 minus 25 minus 32. And I'm left with just 8 solo root beer enjoyers, connoisseurs, you might say. And then 115 Coke minus the 27 and 25 and 18 of overlap. I get 45 Coca-Cola elitists. It is the only pop worth drinking. So, now that we have all this filled in, let's look at some of these questions. Number of students that only like Coca-Cola, right? That's the area I just found. Only means it's exclusive, just Coke, none of the overlap. And we are at 45. Determine the number of students that like Coca-Cola or root beer. So this is Coca-Cola Union root beer, which means I'm looking here. Let's get a different highlighter. Let's see this. I'm going to look at, and I'll erase this one, only Coca-Cola or only root beer or where they overlap. So I need to include even these people that also like Sprite, right? Because if you like Coke or root beer and Sprite, that's okay. So I have 1, 2, 3, 4, 5, 6 different areas that I'm looking in. I need to make sure I include all of these. So it is 45 plus 27 plus 18 plus 25 plus 8 plus 32. Right, that gives me all 3 areas of students that like Coke, students that like root beer, and students that like all 3. And so I end up with a total of 155 students. In this specific set, right? Coke union root beer, Coke or root beer, or both, with or without the addition of Sprite, right? Determine the number of students that do not like any of these 3 soft drinks. So we didn't fill that one in yet. Let's take a look at the question again. I polled 185 students. And it seems like there may be students who didn't like any of these 3. So I'm going to consider all of these situations. Trying to erase things. Let's get this out of the way. Make it a little less messy. Oops. I'm going to do 45 plus 25 plus 8 plus 18 plus 25 plus 2 plus another 25. And I'm going to subtract all of that from the 185 total students that I polled. Right, because this is the students who like at least one of the sodas. Turns out I'm left with 5 students that don't like any of them. So I have 5 students in this school who were polled that said, no way, Jose, soda is not for me. So 5 students don't like any soda. Right, or maybe they're cream soda people. Who knows? They're just not Coke, root beer, or Sprite fans. Maybe they like Pepsi, Barks, and 7-Up. All right, here's one for you. We're going to talk about 130 students playing some school sports. Pause, take a minute to try it. We'll go through it in a sec. See if you can input all this information into that Venn diagram below, talking about football, basketball, and volleyball. All right, so let's look at this. Again, I like to start from the bottom, or generally the more specific information, and work my way up. So first thing I'm seeing is that 10 students played all 3 sports. So I'm going to go ahead and put 10 right in the middle. Next, 17 students played football and volleyball, right? A reminder, a good way to think of this. Football intersect volleyball. I know I'm not asking you to define the sets, but it's always good to think about what we're actually talking about and how we could write that in set notation. So football and volleyball. I'm talking about this section here, the intersection of football and volleyball. If 10 already play all 3, I'm left with 7 for just football and volleyball. 21 play basketball and volleyball. So I'm at 11 in just basketball, volleyball, minus that 10. 13 play football and basketball, so I have just 3 that play football and basketball only and no volleyball. Then 57 students play volleyball. 57 minus 10 minus 11 minus 7, get 29. 55 play basketball. 55 minus 3 minus 10 minus 11, 31. And football, 48 minus 3 minus 10 minus 7, I get 28. Last thing to check is there anybody who doesn't play any of these sports, right? Is there anybody left outside? And so let's see. I had 130 students. Subtract everybody in any one of these sets or intersection of sets or union of sets. 28, 3, 10, 11, 31, another 11, 29. Means I'm left over with 11 total students that play none of these 3 sports. So, students that play only basketball. We have 31 students. Students that played football or volleyball. So F union V. So that would be any of this section, all of football or all of volleyball, including where they overlap. So 28 plus 3 plus 10 plus 7 plus 11 plus 29. Turns out that there's 88 students that play football or volleyball. And lastly, the number of students that did not play either sport or any of these 3 sports. That was that 11 students we found up above. All right, last example. A group of 150 students were asked which of the following shows they've watched on Netflix. Every student has watched at least one show. Right, so that's a good way of telling me that there's nobody outside. Right, looking for those keywords, thinking about why is this information given, right? What does it pertain to? 102 watched Stranger Things, 70 watched Black Mirror, 40 watched RuPaul's Drag Race, 5 watched Stranger Things and Black Mirror, but not RuPaul's Drag Race. We'll get to these in a minute. 7 watched Stranger Things and RuPaul's Drag Race, but not Black Mirror. And 10 watched Black Mirror and RuPaul's Drag Race, but not Stranger Things. Use a Venn diagram to determine the number of students that watched all 3 shows. So here, similar to the last example in lesson 3, I'm given a lot of things in relation to other things, or in this case, I'm talking about things that are in 2 sets but not a third, and never explicitly telling you this last point here. Number of students that, watched all 3 shows. So I'm going to go ahead and call this X. Right, and technically, X is the intersection of B and S and R, right? Black Mirror and Stranger Things and RuPaul's Drag Race. So, let's see where all of this information falls. So again, those first 3 points are very general. I want to look at the more specific first. So I have 5 students that watch Stranger Things and Black Mirror, but not, or and, the complement of RuPaul, right? So S intersect B intersect R prime. So what is that talking about? Well, let's worry about just Stranger Things and Black Mirror first. Right, this is S intersect B. If I then include the intersection of not R, essentially I'm cutting off this segment here where the R is included. So I can get rid of that all 3 section, and really this is what this is telling me. Where are S and B overlapping, but excluding the point where it also overlaps with R. So that's what this 5 is. This 5 goes right here. Let's look at the next one. 7 watch Stranger Things and RuPaul, but not, or and the opposite of, and excluding Black Mirror. So that would be over here. Where does S intersect with R, but excluding the part where it intersects with B? And I had 7 students there. Lastly, B intersect R, intersect not Stranger Things. So that's this external section here. And I had 10 students there. Right? So thinking to yourself, right, working it step by step, find where B intersects R, and then if there is anything there, make sure it doesn't include S, right? Make sure it's only including parts that are part of S prime, right, or not part of that circle S. All right. So that gets us started. I'm going to erase these now, keep the numbers in. I know 102 watched Stranger Things, 70 watched Black Mirror, 40 watched RuPaul's Drag Race, and 150 students are there total. So I've used up this information, right? We're good on these points. We now kind of want to see what else we can do with some of these. All right, so 40 students watched RuPaul's Drag Race, right? The total of set R should be 40. So 40 minus 10 minus 7 minus x is the value of R. I don't know x yet, but I know that this whole thing should total to 40. So I can give it an expression at least. I can say that 23 minus x is what's just in set R, right? Totals to 40, but 10 are taken up, shared with Black Mirror, 7 are taken up, shared with Stranger Things, and x is all 3. So we'll leave that expression for now. Let's do the same thing for Black Mirror and Stranger Things. I had 70 watch Black Mirror, so explicitly Black Mirror with no overlap, no intersections, is going to be 70 minus 5 minus 10 minus x, which is 55 minus x. Right, because again, I know that essentially what this is telling me is that this section here totals to 55. I just need to figure out what x is so I can then reduce that by that amount. S was 102. So 102 minus 5 minus 7 minus x. I get 90 minus x. We've used all the information we have except for one piece. So 150 students watched Netflix, and we said that every student watched at least one show. So I know the outside, right, the universal set has nothing exclusive to just that doesn't fall in here. So here's what it's going to look like. 150 is equal to all of these sections combined. So everything in set S. So the 90 minus x, and the 5, and the x, and the 7. And then everything in Black Mirror, the 55 minus x, and the 10. And the 5 and the x, but I've already included those. And everything that's left over in R, which is just the 23 minus x. Right, the sum of all of these things, 1, 2, 3, 4, 5, 6, 7, double check, 1, 2, 3, 4, 5, 6, 7, right, all of those areas combined has to total to 150 students. So let's simplify this expression a bit, right? I'm worried about some of my x's. I have a minus x, a plus x, a minus x, and another minus x. That leaves me with minus 2x, right? Because I'm at minus 1. I add 1, I'm at 0. I subtract 1 more, subtract 1 more. And then we'll get a different color. I have 90 plus 5 plus 7 plus 55 plus 10 plus 23. I end up with a plus 190 when I add all of those together. And now I'm just solving for x. I'm going to subtract 190 from both sides. I have something that looks like negative 40 equals negative 2x. I divide both sides by negative 2. And it turns out that x is 20. And remember, what is x? Well, x was right here in the middle. X was the overlap of all 3 shows. So 20 students watch all 3 shows. Right, and that's all I technically needed. I could go in and fill out these other values now that I know the value of x. Right, I could say that the people who watch just Black Mirror is 55 minus 20, so there's 35. I could say the people that watch just RuPaul is 23 minus 20, so just 3. People that watch just Stranger Things, 90 minus 20 is 70. But this was the piece of information the question was asking for, and I was able to find it. So again, right, when you do not know something and you cannot know it, right, without making some sort of guess, we want to use algebra instead, right? set something equal to X. Generally, the question will tell you what to set equal to X, right? Whatever the question is asking for, let's make that our variable. And with that, we are done set theory. You have access to practice for this lesson on D2L, as well as the unit review. Make sure you are feeling prepared. If you have any questions, please contact your teacher. Complete some more practice, right? Make sure you're confident doing the material on your own. And best of luck on the set theory unit.